Guys, so I'm gonna teach you guys how to compute for the angle with the horizontal with the experiment we did. This first one is when the motor encoder was set to -61. Alright, so these are the kinematic equations we're gonna use to solve for this case 2 projectile motion problem we're faced with. So let's start with this one. As I may have mentioned, the total time was 0.54 seconds, so we're gonna cut that in half because we're solving for until the maximum height of case 2 first. So it's half of the arc, so we just half the time first. So we do this formula: VFY equals VIY plus GT. Plug in the values. As you can tell, I put the units. Like, don't forget the units. If you forget the units, if you're like, it's gonna be unprofessional of you, and you may get criticized. Or if you during a test, you're gonna get deduction. Now, after solving for VIY, you have to solve for VX. So the formula is VX equals DX divided by T. Plug in the values, you end up with VX equals 0.06 meters per second. Then we get DY. Plug in all the values as seen there, and then it becomes 0.36 meters. Now, next part, I compiled all the data we got up here for us to see, and we can, just to know what's happening. So since we have Vx and Vy, we can now calculate for velocity. So the formula for velocity is Vx squared plus Vy squared, and you get square root of that. Plug in the values, you end up with velocity equals 2.65 meters per second. Now, this is the tricky part. Here, this is how you get the angle on, like, for Vx. So what you do is you copy this formula. This is the formula here. And then you plug in the values, you transpose, you got transpose, so we can isolate theta, put it here, do the equation, you end up with 88.7 degrees. Now, you're gonna ask me, this is all numbers, how does it look like in an actual arc form and everything? And that's a good question. It ends up in arc form like this. So this is dx, distance on the x-axis, 0.3 m. dy is 0.36 m. Maximum point always 0 in case 2. This is 0.06 meters per second there. That's the VIX. This is, of course, the angle. And that is the velocity on the y-axis, which is 2.65 meters per second. Now, let's say you're given the initial velocity, initial velocity, and you're given an angle, but you want to solve for Vx and Vy. So what you do is you get the initial velocity, multiply it with cos for Vx, sin for Vy, put the angle in, and you get Vx and Vy. Now, this method may be used to either solve for them or check if your angle's right, because if you're solving for the angle, such as what I did, how I knew that we were correct was after solving for all of this, after getting all of that and then putting it here, I did this formula right there. And if you do it with your calculator right now, 2.65 multiplied by cos 88.7 degrees, or 2.65 multiplied by sin 88.7 degrees, the same you're gonna get the same Vx and Vy that we did up here using this formula in the back. Alright, let's move on to the second one. Now, all throughout these videos and where I teach you guys how to solve it using kinematic equations, we will just be using this formula. So that paper will literally stay still, not move at all. I love it. It's clipped on. Let's get started. So, following the same formula as a while ago, we've got to solve for VIY first. So we use the formula we know. VFY equals VIY plus GT. Plug in the values, you end up with 2.35 meters per second. Then we move on to Vx. Same formula, Vx equals dx over t. Now note that Vx, for those who are confused, Vx is Vix because it's always constant on the x-axis. So plug in the values, you end up with 0.06 meters per second. Dy, same formula, dy equals VIY multiplied by t plus gd squared divided by 2. Plug in the values, you end up with 0.28 m. Like the last video, and for the next video, I will always, there's this format I'm going to be using. After solving, I'm going to put what we have given up here, and we have to solve for these two now. So, since we have VIY and Vx, now we can solve for velocity. How we do so is Vx squared plus Vy squared. Plug in the values, get square root, and you end up with 2.35. I would like to apologize here, but meters per second. So continuing, V cos theta equals Vx. We plug in the values, we transpose, cancel out, isolate theta, and we end up with 88.5 degrees. Now, how would it look like on like with the arc and everything? Here's how it looked like. 0.03 is the dx, 0.06 is the initial velocity in the x-axis, dy is equal to 0.28 meters. Of course, maximum is always 0 in case 2. VIY is equal to 2.35 meters per second, and the degrees is 88.5. To check it, we do the same thing we did last time, and what we did last time is, I will get it and show it. What we did is, we got this, plugged in the values, and solved for it. Now, of course, since this is a different angle compared to this one, you put this angle in place of here and plug in whatever values you have left. Let's move on to the last one. For the third one, once again, same formulas. You know the drill. Let's get right into it. So, first of all, we're fine for VIY. You know, the total time here is different though. It's 0.41. Divided by 2, we get 0.205 seconds. So plug in the values there, we get 2.01 meters per second is our VIY. Then we need to get Vx. Vx equals dx divided by t. Plug in the values, we end up with 0.07 meters per second. Now dy equals VIYT plus gt squared divided by 2. Put the given, and we end up with 0.21 m meters, either way. So as usual, I put the values we know up here, and now we're going to solve for velocity. Velocity is Vx squared plus Vy squared, and we get the square root of that, which equals 2.01. And then at this point, you guys already know how the transposing and the isolating of the theta works here. You do just that, you end up with 88. And then here's the drawing figure. This is dx, 0.3 meters, Vix, 0.7 meters per second, dy is 0.21 meters, Vf is 0, big maximum point, case 2, VIY, 2.01 meters per second, and the angle is 88 degrees. Alright, now for the final computation. So, with this given arc, this is the same one as this one. I'm not sure if you can see it. This. I'm just gonna rewrite it, and instead of giving it just 1, 2, 3 points, we're gonna give it 5. Alright, so these 5 points are initial starting point, somewhere in between the path going up, maximum height, somewhere in between the path going down, and final where you are, final position. So let's do this initial position first. So down here are the formulas we're going to use. VFY equals VIY plus GT, VFY squared equals VIY squared plus 2GDY, and VX equals DX over T. And wait a minute, I forgot to add something. So there's one more formula which we're gonna have to use, which is obviously V equals square root of Vx squared plus Vy squared. Okay, just add that formula right in. Now let's get started, shall we? So here's our first one, just for 0 seconds. So as let me just move it closer for you guys. All right. As we've learned before, it's all about knowing what's given and plugging in the values. So, since this is carrying over from a past example, from the third equation we did, everything remains the same. VIY is, the VIY is still 2.01, Vx is 0.07. Then, with this knowledge, we can get right into the kinematic equations we know. So, we do number 1 to find VFY. VFY equals VIY plus GT. Plug in the values, we get 2.01 ms. M over S. To find Vx, we do the formula Vx equals dy over t. Plug in the values, we get 0 because simply 0 seconds, anything multiplied by 0, law of 0 is 0. And then we have Vfy squared equals Viy squared plus 2gdy. Plug in the values, this will end up as 0, and 0, if 0 is a numerator, is automatically 0. Now, Velocity, plug in the values, you do it. It's just 2.01 ms. Now let's move on to the second one. The second one is practically the same. We honestly don't have to go through it anymore. It's just the same one as last time. Just knowing the values, plugging them in, and then finding the velocity. Now this is where it gets complicated. Actually, not yet. Not yet. We can still do this one. This one's alright. These first three from here, let me put this. From 0 seconds to 21 seconds, it's the same. The same way of solving it. Nothing different. Just find your values, figure it out. It's basic. I'm pretty sure that it is Kaya. Wait a minute. Yeah. All right. So this is where things get started different. Let me just put this here. So the thing is, case 2 is all the way there. But if we're gonna get this, we're gonna have to cut this here. Alright, so I'm gonna try to block this out like that, and if you look at it carefully, it becomes case 1. Alright, so in case 2, VF is equal to 0. But in case 1, it's somehow free fall, because VF was 0. That means the velocity is 0 at this point. Therefore, it's literally it's 0, dropping there. So if you remove this, and we look at it like this, it becomes case 1, free fall. So this becomes VI, and it's now equal to 0, which is why we still retain the same formula, but we change it up now. Now, instead of looking for... Wait, I remember this. I'm kind of lost. Oh yeah, it's practically the same thing. But now, we're looking for VF. Of course, the value definitely has changed. As you can tell, VI is actually 0 now instead of 0.07, because it can't be anymore. This is practically case 1 at this point. And then we do the same values. Vx equals dx over t. Plug in the values, we get 0.2 meters. This one, we do vfy squared equals viy squared plus 2gdy. Plug in the values, make sure you don't forget your units. You end up with 0.54 m. Do the velocity. You end up with a square root value. Now the principles from here carry also here. Now the only thing you need to really notice in difference from these two is simply because this one, when it's like this, is practically case 1 already. When we see it like this, it's still going up. Therefore, we can do normal formulas. So the angle affects the component of velocity that is in the horizontal direction and the component of the velocity that is in vertical direction. Now, it may be overlooked, but the angle actually does have a lot on how far it goes, how long it stays in the air. It's really fantastic, and I really think that the angle with the horizontal is something no one should overlook, and that everyone should remember to solve and say, hey, we need to get the angle with the horizontal. You know, we gotta make sure it's complete. It explains a lot. It makes a lot of sense. Yo guys, thanks for watching the video. I really hope that you guys learned something from us. I really hope that we could have imparted what we're learning in our physics class with Miss Jessa Joy Ataide and what we're learning from our robotics class with Sir Morris Banya here in DLS USTC. If you have any questions, feel free to hit us up on Facebook, Instagram, Snapchat, whatever you got it. We have it. We're millennials. Anyways, guys, peace out.